In the theater of heavy industry, processing usually involves the cold precision of steel, silicon, or petrochemicals. But deep in the humid tropics, a fleet of flatbed trucks hauls a cargo that defies standard manufacturing logic. This is the jackfruit. To the botanist, it is Artocarpus heterophyllus, the largest tree-borne fruit on the planet. To the engineer, it is a geological nightmare, 50 pounds of irregular geometry, armored in a spiky rind, and saturated with a latex sap so adhesive, it is often utilized as nature's superglue. Every 24 hours, this sterile processing facility intakes 50,000 pounds of this biological armor, the equivalent gross weight of an F-18 Super Hornet, delivered in green prehistoric boulders. The mission is an engineering paradox. Take this rigid, fibrous fruit, which structurally resembles dense timber more than food, and transmute it into a substance that mimics the exact tensile strength, tear resistance, and mouthfeel of slow-cooked pork muscle. This is a high-velocity particle accelerator for organic matter. From the hydraulic guillotine exerting 10 tons of tectonic pressure to the hypnotic shredders spinning at 3,600 RPM, the spiky green giant is dismantled, re-engineered, and resurrected as the future of meat. The operation begins at the loading dock, where raw inputs arrive not as uniform widgets, but as chaotic biological variables. Unlike a potato or an apple, no two jackfruits share the same dimensions. They are lumpy, oblong, and covered in thousands of conical spines that act as organic shock absorbers. Standard agricultural harvesting takes place under the sun, but here, the clock starts ticking the moment the stem is severed. The fruit is immediately transferred to the intake zone, a climate-controlled staging area where the temperature is dropped to arrest the ripening process. If the fruit ripens, the sugars spike, the texture turns to mush, and the entire 50,000-pound batch becomes useless for meat simulation. We need the fruit, young, green, and structurally rigid. Precision-trained technicians load the fruit onto a heavy-duty incline, pleated belt, a reinforced rubber system designed to grip the spiky exterior and haul the heavy loads upward toward the first and most critical bottleneck in the line, the decortication chamber. The enemy here is geometry. A standard industrial peeler uses a fixed blade against a rotating object, which works for a sphere, but a lumpy jackfruit in a standard lathe would see the blade gouge the high spots and miss the valleys, resulting in a yield loss of over 40%. To solve this, the facility utilizes the Atlas Pacific Auto Contour Rotary Peeler, a machine originally designed for the erratic shapes of melons, now hot-rodded for heavy-duty fibrous armor. The process is a violent ballet of pneumatics and sensing technology. An operator secures the 20-pound fruit between two pneumatic chucks, spiked steel clamps that bite into the core. And once the safety cage locks, the motor kicks in, spinning the massive fruit up to 400 revolutions per minute. As the fruit blurs into a green streak, the sensor-guided spring-loaded tracing blade engages. It floats over the bumps and dives into the valleys, maintaining a surgical depth of exactly 0.2 inches, reading the fruit like Braille at high velocity. A continuous ribbon of green spiky skin flies off in a perfect arc, driven by centrifugal force, revealing the stark white cylinder beneath. But the machine is fighting a secondary enemy, latex. As the skin is severed, the fruit bleeds a white, sticky sap containing natural rubber that can seize the mechanical arm if the blade pauses for even a fraction of a second. High-pressure water jets blast the cutting point continuously, acting as both a lubricant and a coolant, leaving a naked white, drum-shaped cylinder of raw fiber ready for the next stage of demolition. The peeled cylinders travel down a stainless steel gravity chute to the coring zone, where the engineering challenge shifts from surface geometry to internal density. The center of a jackfruit contains a solid, woody core that is inedible, bitter, and structurally harder than oak. Attempting to remove this core with a rotary saw creates friction, activating the remaining latex and gumming up the saw teeth within minutes. To solve this, the facility relies on the brutal simplicity of hydraulic pressure through the custom JBT hydraulic guillotine splitter. The metaphor here isn't slicing, it is tectonic shifting. The white fruit cylinder is centered on a V-shaped steel cradle beneath a titanium wedge blade honed to a splitting angle. When the operator engages the dual-hand safety switches, a hydraulic ram drives the wedge downward with 10 tons of vertical force. There is no spinning, no heat, and no noise until the moment of impact. The blade drives through the center axis, forcing the fibers apart with a deep, mechanical groan, followed by a sharp, dry crack that echoes through the monolithic facility. The fruit splits cleanly, exposing the triangular cross-section of the woody core for a team of technicians using pneumatic handheld rotary tools to excise the waste. This is a race against oxidation. The moment the flesh is exposed to the facility's air, enzymes begin to turn the white fibers brown. Speed is paramount. The coreless chunks are tossed onto a vibratory conveyor that shakes loose any remaining seeds or rigid fragments, preparing the material for its chemical exorcism. At this stage, the raw chunks are still coated in a microscopic film of latex sap that would act like industrial adhesive in downstream equipment.
Override it.
You cannot wash this off with soap. You must dissolve it chemically while altering the cellular structure. The chunks drop into the throat of the Lyco Clean Flow continuous rotary blancher, a monolithic stainless steel cylinder that functions as a horizontal pressure cooker. Inside, a specialized solution of water and citric acid is heated to 200 degrees Fahrenheit. As the internal screw auger forces the fruit forward through the boiling liquid, the intense heat denatures the proteins in the latex, breaking its chemical bonds and rendering it inert. Simultaneously, the citric acid lowers the pH to neutralize the bitterness. If we could see inside, we would witness a chaotic whitewater rafting expedition as the fruit is tumbled violently in a turbulent, acidic solution. This hydroflow agitation ensures every cubic millimeter of the fruit is battered by the thermal solution, reaching the required kill temperature. After 12 minutes of thermal submersion, the fruit is no longer rigid wood, but pliable fiber. It drops immediately into a hydrochiller bath of near-freezing water to arrest the cooking process instantly. This shock and lock technique preserves the muscle-like texture, keeping the fibers distinct and tough for the most violent stage of the process, the hypnotic shred. This is where fruit becomes meat. The challenge is visual deception. If you cut a jackfruit with a sharp knife, the edges are too clean and geometric. To fool the brain into seeing pork, the edges must be ragged, frayed, and chaotic. We need to destroy the structural integrity of the fruit without slicing it, using a battery of Urschel model CCDL shredders, the culinary particle accelerators of the food world. Inside the stainless steel drum, a central impeller rotates at 3,600 RPM, creating a spinning vortex. Here is the engineering twist. Technicians have intentionally equipped these machines with dull impellers. Sharp blades would slice. We want tensile failure. Centrifugal force, generating roughly 500 Gs, slams the fruit chunks against the stationary outer ring of the shredding head. Because the impellers are blunt, they drag the fruit through small openings, causing the fibers to pull apart longitudinally like string cheese being ripped at 3,000 revolutions per minute. The fruit explodes. Solid white chunks enter the top and vanish into a blur, discharging from the bottom as a mountain of soft, ragged fibers. Quality assurance specialists monitor the output on a backlit conveyor belt, looking for shards of the core that survived the splitter. The shredder acts as a natural filter. Hardcore pieces don't shred, they bounce, alerting technicians to adjust the impeller gap. The output is now a pile of neutral white fibers with the exact resistance of cooked pork shoulder. But it is bland cellulose. To give it soul, we have to force liquid into a solid that doesn't want to drink. Jackfruit fibers are naturally hydrophobic, resisting the oils and sauces needed for a meaty profile. The solution is the GEA Scan MIDI Vacuum Tumbler, a monolithic, rotating steel drum holding 5,000 pounds of product and functioning as a mechanical lung. Technicians load the white fiber and a precise slurry of spices, oil, smoke flavor, and beat red natural coloring into the drum before sealing the door with the weight of a bank vault. As the drum rotates at a rhythmic 8 RPM, a vacuum pump drops the atmospheric pressure to negative 0.9 bar. Under this vacuum, the air and moisture trapped inside the cellular walls expand and are sucked out, causing the fruit to bloat and gasp for equilibrium. Then the system triggers a hard vent, rushing atmospheric air back into the drum instantly. The pressure collapses and the bloated fruit cells snap shut, inhaling the BBQ slurry instead of air. In a split second, the pale white fibers drink the red liquid deep into their core structure, a forced infusion at the molecular level. When the drum opens, the transformation is startling. The white vegetable matter is now a glistening in a deep red mound, visually indistinguishable from pulled pork, with beet juice mimicking myoglobin and smoke oil mimicking a wood fire. But this product is a perfect breeding ground for bacteria and must enter the kill zone. The seasoned product is weighed by multi-head scales that calculate the perfect combination of clumps to hit a 10-ounce target within a fraction of a gram before being dropped into multi-layer polymer pouches and heat sealed. To make this shelf-stable without refrigeration, we must annihilate every biological organism in the bag, including the spores of botulism that thrive in anaerobic environments. The pouches are rolled into the Allpac's water spray retort, a solid steel pressure cooker where the door locks with pneumatic bolts. Superheated water and steam are injected until the chamber reaches 250 degrees Fahrenheit, while air pressure is pumped in to prevent the bags from exploding. For 45 minutes, the heat penetrates to the geometric center of every pouch, cooking the spices into the fiber and killing any bacterial spores. A cool-down cycle then blasts the racks with cold water, shrinking the pouches tight against the meat to create a vacuum brick. The surviving pouches travel to the final sentinel, the Eagle Pack X-Ray. This is a density scanner that looks through the sauce and fiber to identify any foreign objects. If the computer algorithm detects a shard of titanium or a stone as small as 0.8 millimeters, a jet of compressed air fires with sniper-like precision, blasting the offending pouch into a locked reject bin. At the end of the line, a robotic arm stacks the finished cases onto a pallet. From green spiky boulders to sterile pouches, the transformation is total. We haven't just processed a fruit, we have tricked the senses. By utilizing the physics of hydraulic splitting, the chemistry of acid blanching, and the mechanics of tensile failure, this facility has turned a tropical giant into a backyard BBQ staple. This 50,000-pound run utilized 1/10 of the water and 1/20 of the land required for actual pork, keeping waste below 18% thanks to auto contour peeling and vacuum infusion. As the delivery trucks roll away, they carry not just food, but a feat of high-efficiency edible engineering. The jackfruit has been tamed, shredded, and repackaged for the modern world.